So let's go ahead and start simplifying. In the numerator, we see we're doing the cube root. Well, the cube root of 8 is 2, so I know that's going to come out perfectly from the cube root. The square root of 4 in the denominator is also 2, and I know the 2's will cancel. So I should definitely not have any more numerical values that aren't associated with a variable. So looking at the answer options, I could right away eliminate options C and D. Now let's continue. When you're doing, let's say, a cube root, or whatever root for that matter, the trick when you're dealing with variables is you can ask yourself, well, how many times does 3 go into 8? It goes in perfectly a total of 2 times. So I didn't give myself much room here, but it's going to be x to the second comes out because 3 goes into 8 twice. With how much left over? Well, 2 times 3 is 6. So there's 2 left over from 8, and that x to the second goes inside. Let's do the same thing with the y to the 6. 3 goes into 6 exactly twice. So a y to the second comes out, and there's no remainder, so no y's go under the root. So an x squared y squared came out, and the cube root of x squared stayed inside. Let's do the same thing with the denominator. Now, know that there's an unwritten 2 out there. Same way that if I say x squared, squared means 2, square root also means 2. So how many times does 2 go into 2? Well, it goes in perfectly 1 time, so an x to the first comes out with nothing left over. 2 goes into 6 3 times perfectly with nothing left over. So there's not even going to be a root in this denominator. And then let me go ahead and rewrite this because I got a little sloppy. So you have x squared, y squared up top, and then you have the cube root of x squared all over x, y cubed. Well, the way I like to do properties of exponents is I ask myself, where are there more x's, top or bottom? And then how many more? Well, there's only one more up top, so an x to the first remains. Where are there more y's, top or bottom? More in the bottom, and there's one more in the bottom. Now, I could have done the normal property of exponents of saying, okay, let's say with the y's, I'll do 2 minus 3, and that gives me a -1, and then I have to rewrite that as 1 over y. To me, that's a little bit complicated. I'd rather avoid a potential negative exponent because students really tend to struggle with negative exponents. I would definitely encourage you to refresh on page 34, which is side 3 of your math reference document, and notice our 5 properties of exponents. We just talked about the property here of subtracting the exponents when you're dividing powers, and we also referenced the negative exponent. But again, by utilizing this trick of saying where there are more y's, top or bottom, and how many more, you can avoid that entirely. And then we still have the cube root of x squared here. And that ends up matching with B.